Oh, good morning, everyone, and welcome to the first Physics 120 hybrid exam prep party. And we will have two sessions, okay, today and also tomorrow. Tomorrow will be from 12 p.m. to 1:30 p.m., okay? And as you know, we have couple of practice review problem for unit one. Some of them that are handout, okay, graph handout, and one of those is just a D12 quiz. Good. So my plan is today to start with the D12 quiz and try to complete this part first. And if we have time, we can move on to the, graph problem questions. Okay. So if we couldn't, I will try to cover those tomorrow in tomorrow's session, just in case if you cannot attend to the tomorrow session, I I'm gonna record this session and also tomorrow's session. You can send me an email, to this address. So or GHORBANA @star.lcc.edu. You can send me an email, and I will be sending you the recorded session. Okay. My plan is to just record all exam prep parties for Physics 120. Again, just in case, if you couldn't attend to any of those, send me an email. I will try to share the link of the recorded session with you. Okay, so if you are ready, and how the exam prep is going to look like. Okay, there are some questions, like this, multiple choice question. You don't need to do any calculation. Good. So we will try to go very fast with those questions. Okay, but if you have any question, you can ask why this is the right answer. Okay, I thought that this is the right answer. Could you explain me more? So I will try to explain more. Good. And sometime I'll give you time to work on some question by yourself and then ask me question. Then we will go over the problem together. Sounds good? Okay. We start with the practice exam. I hope every all question are same. Your instructor may have changed some of the problem. If they are not saying, okay, don't worry, okay, this is going to be just a practice, okay, those problem they have changed, they are kind of same problem but bit in different format. Good. So okay, we're going to start with question number one. um, Question number one, it's telling the synthesis of a large collection of information that contain well-tested and verified hypotheses about certain aspect of the world is known as a scientific hypothesis, okay, theory, fact, law, or principle, none of the above. Which one do you think is the right answer? Well-tested and verified hypothesis. Theory. Yeah, okay. Well-tested and verified hypothesis, okay. They will theory. Theory will be tested, okay, and then it's become law, okay, like a Newton first law, second law, third law. Good. So this one is theory. Good. So in science, an educated guess is called hypothesis. Theory, okay, it's well tested and verified. Good. Hypothesis can be wrong. You guess something.
Theory become principle or law.
When theory is tested with all scientists around the world, okay, they set up the same experiment, they test it and get data, and they say, okay, oh, we got the same thing. Okay, it's the global law theory. Okay, it's become a fact, a law principle. Okay, Newton first law, second law. That you know, educated guess. It doesn't need to be correct. It will be tested later, and then we will find out, or educated test set will be matched with what we have found. Good. So educated guess is called hypothesis. Okay. So hypothesis can be wrong or can be right. So this is statement. There are regions beneath Earth's crust that will always be beyond the reach of the scientific investigation. It's the scientific statement, it is a hypothesis, it's the speculation, it's fact, it's theory. Yes. There are regions beneath Earth's crust that will always be beyond the reach of scientific investigation. Is a scientific statement, hypothesis, speculation, fact, and theory. This is different than hypothesis, okay? Hypothesis is educated guess, okay? But this is a speculation. So you do know some stuff already, but you are not 100% sure, okay? So that's why you speculate, okay? So this is a new definition. Good. Hypothesis is educated guess, but you haven't tested anything yet. Okay, you don't have any idea. You just say, okay, the mass increase, velocity increase, but you will test it, okay? But the speculation is different, okay? You know some stuff, okay? You're trying to understand more. Question number 4. Science and technology are responsible for all the bad in the world related to one another, but not the same thing, fundamentally different from each other, responsible for all the good in the world. Perfect, yeah. That's a perfect, explanation. Related to one another. So if experimental findings are not reproducible, so it means that you do you set up the experiment, you get some data, okay, and then you ask someone else, some other scientist, okay, to do exactly the same experiment, but you will not get the same result, okay. So what does it mean? Okay, the results are considered valid but not reusable. It is an indication of a scientific fraud. The results are not considered valid. It is an indication that the scientific method was not followed. Yeah, this is all not considered valid. Okay, so it means you get something. Okay, the results are not valid. Okay, so yeah, the results are not valid. Okay, are not considered valid. Good. Okay, so here we start motion. Okay, so you have a formula sheet. Yes. Okay, so let me just put the formula sheet here. Okay, so somewhere. Okay, I'm gonna just. Where is the formula sheet? Oh. Getting started, test, extra link and resources. There you go. I am gonna download the formula sheet, download, and then open it here. And before moving to the next problem, okay, I would like to just show you, okay, so let me just put this here. There you go. Okay, this is gonna be here. Good. So you have this formula sheet, okay? So before moving to the problem, okay, I'm gonna just, go back and forth from formula sheet to the question. And then, it is important because you will have a formula sheet. You read the problem, you just go back to the formula sheet to see which formula is helpful, can help me to solve this problem, okay? So again, we need to know what each formula means. For instance, here, okay, delta v is equal v final minus v initial. Change in velocity. We have a car, it's moving and its velocity is changing, and it's asking you calculate the change of velocity. What you do, you just subtract final velocity minus initial velocity, v final minus v initial. Sometimes we just show it v final, vf, vi. Good. F represent final, I represent the initial. Speed. Speed, yes.
Does change in d is d distance and then change?
Yes.
Is it always going to be final minus initial?
Yes. Delta means change. It can be change in temperature, change in distance, change in velocity, change in time. Okay. So here it's changing delta V. It changes velocity. Good. So let me just change the color. So the next one, speed. Speed is the distance traveled over time. We don't care about the direction. I say you're driving car. I call you. I say, okay, what is your speed? Okay, you say 50 mile per hour. That's it. 50 mile magnitude number. Give me a number. 50 mile per hour. But if I ask you what is your velocity, you say my velocity magnitude is 50 mile per hour, but I am heading toward to the Ann Arbor. The direction become important. That's the difference between the speed and velocity. Speed is delta, distance over time, the distance traveled over time, how much it take, okay, to travel, let's say, 100 mile, okay, 100 mile divided by, let's say, 2 hours is going to be a speed. But it's a speed, okay. But what is the velocity? The velocity direction is important as well. So we need a coordinate system. You are moving to the right, you are moving to the left. Probably you have done in the experiment that you just had negative velocity. What does it mean? You were moving in the direction of, in opposite direction of the coordinate system. You have a positive, okay, velocity. It means that you are moving to the right side of the coordinate system, okay? So, and the formula of the speed can be delta d over delta t, okay? So, again, what is the average speed? Okay, let's say sometime you have more than one motion, okay? For 1 hour, you're just moving with this velocity. For another hour, you are moving with that velocity, okay? What is the average? It's going to be total distance over total time. Again, the direction is not important. You say that, I was traveling to the Ann Arbor, but I went to the Howell first, okay? And then, from Howell, I went to the Ann Arbor, okay? So you say, okay, how far how far it's on until Howell, okay, how far it's from you, and then add these distances and divide it by how much time it takes. Good. So, and then, time interval. Okay, so it means that, let's say 30 minutes takes to go to the Howell, another 40 minutes take to go to the, from Howell to Ann Arbor. Okay, so let's say, for instance, okay, it's not exactly 40 minutes. Okay, so what is the time interval? 30 minutes plus 40 minutes. 30-minute time interval for the first distance, 40 minutes is the time interval for the second distance. Add this time together, okay? So we can say total distance traveled. How many distance travel you have? Okay, let's say D1, D2, D3, D4, D5, D6, divided by delta T1, delta T2, delta T3, delta T4, delta T5. Make sense? And this is the formula, okay? Average speed is going to be total distance traveled divided by delta T, okay? So this is in the word form, this is in the equation form. And then you can rewrite this, okay? So for instance, this is the total distance. You can write it D and then rewrite it, okay? Multiply both sides by delta T. Delta T is going to be the next formula, yes? See, these two are the same thing. What is the acceleration? Acceleration is change of velocity. You remember? We just explained the change of velocity here. Change of velocity. When the velocity change, okay, we will have acceleration. This is going to be the acceleration. For instance, free fall. You are dropping object. What is the velocity at the beginning? 0. When you drop, the velocity keep increasing. What happened? We have acceleration. And here in the free fall, it's called gravitational acceleration, okay, which is negative 9.8 meter per second square. But let's say you are driving, okay, I call you right now. I said, what is your velocity? You say 50 miles per hour, okay. 1 minute later, I call you, okay, what is your velocity? You say 60 miles per hour. In 1 minute, your velocity has changed 10 miles per hour, yes? I can calculate your acceleration. I say 10 miles per hour divided by 1 minute is going to be your acceleration. Change of velocity over time. We can rewrite this equation and write V equal A times T. Good? Okay. Okay, let me just erase this. Okay. So again, this equation has changed. Okay, I multiply both sides by delta T, yes? Delta T cancel each other. What happened is going to be V delta V equal A times delta T, yes? The same thing. Oh. Okay, again, this is exactly the same equation, okay? And then if we have a free fall, the acceleration changed to the gravitational acceleration, yes? And then the distance traveled in the gravitational, in the, motion with the constant acceleration, okay? This is going to be the distance traveled. Good. 1 over 2 AT squared. And when we have a free fall, A change to the G. Good. Okay, and then the rest is going to be the weight formula, okay, acceleration formula, net force divided by mass, okay, and then we will come back to all these equation later, okay. So I just wanted to know you that you need to study the equation first to understand each equation, what it means, each equation for you. You can write a note, okay, where to use this equation at what situation, and then, okay, come back to the question, okay. So we, as I said, okay, we go back and forth, okay, to the formula. Okay. Question option. It's sorry. Question 6. Which of the following is not a vector quantity? Vector. Okay, so it means the direction is not important. Speed, velocity, acceleration, all other vectors. All are vectors. We just explained that. Okay, we said that. There you go. The speed, I said the direction is not important. I call you, okay, what is your velocity? You said, but my speed is just 70 miles per hour. I don't care about your direction. Good. So the speed is just a magnitude of, change of position over time. So a horse gallops a distance of 10 kilometer in time of 30 minutes. Its average speed is, okay, which formula I'm supposed to use? Where is the average speed? Total distance covered over time interval, yes? What is the distance of, there you go. The distance of 10 kilometer, yes? Is the total distance covered in how much time interval? Okay, this is delta T, this is D, good? So what is the speed then? The speed is gonna be D over delta T, yes? What is the D? 10 kilometer. What is this? 30 minutes. Okay, what is the 30 minute? It is half an hour, yes? Okay, because you see the units are kilometer per hour, yes? It's better to just convert 30 minutes to the hour. So it's going to be how much? 0.5 hour, yes? So 0.5 hour. What is the right answer here? There you go. 10 divided by 0.5 is going to be 20 kilometer per hour. Okay. A hockey puck is set in motion across a frozen pond. If ice friction and air resistance are neglected, okay, no friction, no air resistance, okay. So the force required to keep the puck sliding at the constant velocity is, okay, read, is 0 equal to the product of its mass times its weight equal to its weight and equal to its weight divided by its mass.
It's not zero.
Is not 0? Okay, look at the equation here. Which equation representing this? Okay, it's telling that it's sliding at the constant velocity. What the constant velocity means?
Speed is not changing.
Oh, there you go. Speed is not changing. Okay, speed is not changing. What does it mean? It means that delta V is 0, yes? Good. You know, speed is not changing. Delta V is 0. When delta V is 0, go down. Okay, what do you see? You see this formula, yes? Acceleration is delta V over delta T. When delta V is 0, yes? 0 divided by time is going to be 0, yes? Acceleration is 0. Okay, you see? Where do you see acceleration for? Oh, there you go. I see acceleration again here. Okay, acceleration is net force divided by mass. Okay, when acceleration is 0, what does it mean? Net force is 0 as well. Okay, the object was moving with the constant velocity, but net force is 0. Net force, there may be some forces. Probably these forces, they were canceling each other. Good. So what is the right answer then? You see how I just, look at this problem? Okay, I read the problem, constant velocity. This is a keyword. I go to the equation. Constant velocity, it means that, what does it mean? V final is equal V initial, yes? Or velocity is not changing. When delta V is 0, I go down here. Okay, I see acceleration. Okay, acceleration is change of velocity over time. When the velocity is not changing, acceleration is 0. When acceleration is 0, okay, I'll go down to find anything related to the force. Acceleration is net force divided by mass. See how many equation I used here? 3 equation. And your job is doing like this, okay? Go back and forth from the paper, the exam, okay, the question to the equation sheet, okay? Back and forth, okay? Look at the equation to see which equation can help you to answer this question. Make sense? Even if there is no calculation, what we still refer to the equation sheet. Okay, number 9. Tell me, okay, just read the problem and tell me which equation from the right side, okay, we are supposed to use. 12 seconds after starting from rest, an object falling freely will have a speed of falling freely. It means that it's moving with the constant acceleration, gravitational acceleration. Which equation in the right side, okay, help you to find the velocity? V equal what?
right?
Yes, there you go. This equation, okay? Because it's telling 12 seconds after starting from rest. Starting from rest, it means that the V initial is 0, yes? How many seconds later? Delta t or t is 12 seconds. Object falling freely. Falling freely, it means that acceleration is negative g, yes? Or g. Good, the magnitude. What is the speed? What is the speed? What is the speed formula? There you go. V equal g time t. What is the g value? Again, negative 10. Good. What is the t value? 12. It's going to be how much? Negative 120 meter per second. What this negative means? Direction is moving down, okay? But here it doesn't care about the speed. We say that it doesn't care about the direction, yes? So it means that we don't need to put the negative, yes? What is important is just the value of the velocity, the object, velocity, yes? Good. So it is 12 meter per second. Sorry, it is the acceleration is 10 meter per second squared. Okay, so again, without sign, multiplied by how much time? So you do get rid of, okay, what is the velocity then? 120 meter, or a speed, sorry, a speed. Do you see the answer here? There you go. More than 100. Okay, any question? Question number 10. Okay, read this and tell me what is the answer, okay, by looking at the equations. If a car increases its velocity from 0 to 60 kilometer per hour in 10 seconds, its acceleration is, which formula is I'm supposed to use? Tell me.
A equals change velocity, change in time.
There you go. That's it. I just write this. A equal delta V over delta T. And what else I am supposed to use? Delta V was what? V final minus V initial, yes? I just rewrite V final minus V initial divided by delta T. What is the V initial? No. V initial is 0. What is the V final? There you go. What is the delta T? 10 seconds. You see? You find the right formula. Okay. Sometimes you just use two formula. Okay. So okay. Did you find that?
Figure out how to change it to hour.
SP to and you see the units is kilometer per hour per second. What does it mean? You don't need to do any unit conversion, yes? Because the time is in second, and then kilometer, velocity is kilometer per hour. Kilometer per hour, and the time is second. Oh, there you go. Okay, I put the time as a second and the velocity kilometer per hour. I don't need to change anything. So, and it's gonna be, A is gonna be, what is the V final? 60 minus, what is the V initial? 0, divided by how much time? 10, okay? So it's gonna be 6 kilometer per hour per second, because the top is kilometer per hour and bottom is second, yes? Okay, you see in this equation, we just use two formula, we just use this formula, and then we just plug delta V equal this, okay? You can drive as many as equation that you like. Okay, you see, I want to drive new equation, okay? And you can even write it down in your formula sheet. You see that we said that A is VF minus VI divided by delta T. Good. What I do, I multiply both sides by delta T, delta T, delta T. What happened? Delta T and delta T cancel each other. What I have, VF minus VI is A times delta T, yes? And then what I do, I just add both sides by VI, VI. What happened? VI cancel each other. What happened? It's going to be VF equal VI plus A times delta T. Good. Again, you don't need to memorize this, okay? So we just keep playing with this formula and drive new formula. Where can I put this here? I can put it here. I can say V final equal V initial is A times delta T. It is when we have this equation, when initial velocity is 0, yes? When initial velocity is 0, is going to be 0. Acceleration is acceleration, yes? And instead of delta T, they just put time, okay? 80, good? So V final is going to be A times delta T. So it's better than, you rewrite this equation and just write this equation. Sometimes you have an initial velocity, okay? And it's better to just write down this formula or use this formula. You see, you should know how to play with the formulas. Okay, ready for the next one? Okay. Question number 11. So those who are at home, okay, so online, just in case if you have any question, please turn on your microphone and then speak up, okay? So when you don't talk, it means that everything is okay. Question number 11. A ball tossed vertically upward rises, reaches its highest point, and then fall back to its starting point. During this time, the acceleration of the ball is always a free fall, yes? When we have a free fall, we have a gravitational acceleration, yes? What is the gravitational acceleration value? Negative value. 9.8, yes? Or 10 meter per second squared. What is the direction? Is always downward. It doesn't matter. You throw the ball upward or you just release the ball. The acceleration is always downward. Okay, so gravitational acceleration is always downward. It doesn't matter. You throw the ball upward or you just release the ball. So when you are throwing upward, we have a speeding up or slowing down. When you throw the ball into the air, slowing because it's go and it's stop. Yes, the velocity is slowing down. When you are releasing the ball from this height. Okay, what happened? It's fall. Okay, but it's speeding up. Yes. Okay. When it's going up, it's slowing down. When it's moving down, it's speeding up. Okay, so and then we know that when we have a slowing down, yes, a slowing down, acceleration and velocity opposite direction. When it's speeding up, acceleration and velocity, same direction. Good? Okay, let me just explain this here. Okay, we have a ball, yes, is moving upward. What happened? Speeding up or slowing down? Slowing. Okay, the velocity was up direction, yes? Because it is slowing down, acceleration and velocity should be in the opposite direction. The acceleration is downward, which is a gravitational acceleration, yes? Okay, this was slowing down. When the ball is on the top, yes, and then moving downward, good? Speeding up or slowing down? Speeding up. This is the velocity direction, yes? Okay, when it's speeding up, what does it mean? Acceleration and velocity, same direction. Okay, what does it mean? Acceleration should be exactly same direction. Okay, you see that? In both situations, acceleration is always downward. Make sense? Good? So that's why, okay, slowing down, okay, acceleration and velocity opposite direction, speeding up, acceleration and velocity in the same direction. And in this situation, when it's moving up, slowing down, when it's moving down, it's speeding up. Acceleration is always downward. That's why we just say that gravitational acceleration is always downward. Make sense this way? Okay. So number 12. Okay. A ball is thrown upward and returned to the same position. Compared with its original speed after release, its speed when it return is about. Yes. You see this formula? V equal GT or VF equal VI plus A times delta T, yes? How much time it takes to go up? Let's say 3 seconds. Let's say we have a ball, yes? It takes 3 seconds to go up. And it takes another 3 seconds to go down, yes? What was the acceleration? Acceleration is G, yes? 10. When it's going up, 10 times 3, yes? 30. Here, when it's moving down, 10 times 3, 30. If it was 30 here, it becomes 0, and it's 0, and it's come down, it's become again 30 meter per second. Here was moving up, here is moving down. At the same location, because it takes same time, okay, to reach the same location. Based on this formula, G times T, G is the same for both, yes? You remember we said G is both is 10 meter per second squared. If the time is same, why the time is same? Because same position. Let's say if you throw the ball 3 seconds to go upward, it takes 3 seconds to come back to the ground. Good? So it's gonna be the same. So, number 13. At one instant, a heavy object in air is moving upward at 50 meter per second. Okay, so again, I use this formula. Good? V final equal V initial plus A times T. What is the V initial? What is the V initial? Is moving upward, yes? V initial is 50 meter per second. Okay. How many seconds later? 1 second later, the speed in meter per second is how much it is? What is the acceleration? -10, yes? Gravitational acceleration. Good. Okay, I plug to the formula. I would like to find the velocity final 1 second later. What is the initial velocity? 50 meter upward, yes? Positive 50. Plus, what is the acceleration? -10. How many second? What? There you go. 50 minus 10 is going to be how much? Okay, let me tell you this way. In the free fall, when you're throwing the ball upward, okay, for each second, velocity decrease 10 meter per second. Good? When you fall, release the ball, okay, for each second, the velocity increase 10 meter per second. For example, okay, this was 50 meter, okay. I want to just keep 50 meter per second at the beginning. 1 second later is going to be how many meter per second? Another second. How many meter per second? How many second later is going to be 20? Okay. No. T equal 1, yes. T equal 2. T equal 3, yes. 1 second later is going to be T equal 4, yes. 10 meter per second. 1 second later, let's say here is going to be 0 meter per second. Good. T equal 5. How many second it takes the ball reach to the highest point? 5 seconds. And it takes another 5 seconds to go back down. Yes? Let me just change the color. Okay. What was the velocity on the top? 0. Yes? 1 second later, the velocity is going to be 10 meter per second downward. Good. 1 second later, the velocity is going to be 20 meter per second, 30 meter per second, 40 meter per second. Yes? And 50 meter per second. Good. So again, we are all using this formula. Hmm? No, I said that I already know. Okay, A was delta V over delta T. You remember that? I said I rewrite this formula. Again, you are supposed to use this formula. I rewrote this formula and then developed this formula. Yes? Okay. And I am using this. But you were able to use this. They are the same thing. Okay. So, but I'm just telling if even if you don't need to use the formula, you should know that the velocity when it's going up is slowing down for each second is a slow down 10 meter per second. Let's say if it was at the beginning, it was 100 meter per second, yes? And you throwing the ball upward, good? How many seconds later the velocity become 40 meter per second? Yeah, 6 seconds, yes? Because it's become 90, 1 second, 80, 2 seconds, 70, 3 seconds, yes? Okay, it takes 6 seconds, okay, to reach to 40 meters. And how many seconds? Okay, one question. If the velocity is 10 meter, 100 meter per second, okay, how long it takes the ball go up and how long it takes to go down? There you go. Make sense? Because how many seconds it takes to become zero, the velocity becomes 0 meter per second? 10 seconds, yes? It takes exactly 10 seconds to reach to the ground. The total traveling time is going to be 20 seconds. Make sense? Okay. Yeah, I just wanted to show the formula first, okay? But again, you don't need to use the formula, okay? You should know, that, speeding up with 10 meter every second, 10 meter per second, slowing down every second, 10 meter per second. Okay. So, starting from rest, yes? What is the initial velocity? 0. The distance a freely falling object will fall in 0.5 seconds is about which formula I'm supposed to use? There you go. Yes? D equal 1 over 2 GT square. Good. Again, 1 over 2. What is the G again? 10. The magnitude is important. Good. We know that it's moving down. Okay. But here is magnitude. Okay. You don't see any negative. How many seconds later? 0.5 seconds later. Okay. Calculate this value. Okay. How much it is? Okay. Let me just 0.5 times 0.5. Yes. Time 10. Yes. Divided by 2. It's going to be 125. Yes.
That's what I got. It just,
125 meter.
none of the above.
None of the above. Okay. Number 15. Read the problem and tell me which formula you are supposed to use.
Even if it's the same one.
Same one, okay. So
Oh, but not the G one. It's,
twice, yes? The gravity.
AT2.
G equal what?
Acceleration. That one?
This one? This one?
Well, because the gravity's not the same. Oh.
What happened? You know, an object falls freely from the rest on a planet where the acceleration due to its gravity is twice much. Okay. So it means that the gravity here is not 10, it's twice. It's going to be 20 meter per second squared. Good. In its first 5 seconds, 5 seconds, what is the t? 5 seconds, yes? What is the distance travel? Okay, again, we're using the same formula, yes? D is equal 1 over 2 GT squared. But G is not on the Earth, on any planet, yes? 1 over 2, what is the new G? 20. How many seconds later? 5 power of 2, yes? 5 power of 2, 25. 25 times 20 is going to be 500. 500 divided by 2 is going to be 250 meter. Yes? Make sense? Any question? Okay. Question number 16. Read the problem. If you drop an object, it will accelerate downward at the rate of 10 meter per second squared. Now, we know that, yes? Perfect. Free fall. If you instead throw it downward, its acceleration will be, oh, we just explained. It doesn't matter you move it. Oh, yes. You know, if it doesn't matter you throw upward or you just release it, the acceleration is always same and is always downward. Good. Which one is the right answer? About 10 meter per second squared. As long as there is no air resistance. Okay, if the air resistance involved, okay, we are supposed to find the total acceleration, okay? Which is definitely, it can be less than g or it can be more than g, okay? But we assume in all problem that the air resistance is 0. No air resistance. Number 17. If a projectile is fired straight up at the speed of 10 meter, the total time to return its starting point is, what is the total time? It's 10 meter, yeah? No, what is the total traveling time? How many seconds it takes to go up? No, how many seconds? It was 10 meter per second, yes? How many seconds? You know, the ball is on the ground, okay, 10 meter per second. How many seconds it takes to go up? The velocity becomes 0. We just said that. Yeah, 1 second to go up, yes? And it takes another 1 second to go down. 2 seconds. You remember I said the 100 meter per second? How many second it takes to go up for 100 meter per second? 10 seconds to go up, yes? Because the velocity decrease 10 meter per second every second. When is it slowing down? When is it speeding up, the velocity increase 10 meter per second every second. Good? So 2 second, 2 second. No, sorry, 1 second, 1 second is going to be total traveling time is going to be 2 seconds. What is 18? A car accelerates at 2 meter per second. So this is the acceleration. Acceleration is 2 meter per second squared. Assuming the car start at, how much time does it need? Okay, how much time? What is the time to need to accelerate to? What is the speed? V final is how much? Which formula we can use? This one or this one, the same thing, yes? Because V initial is 0, that's why it's going to be this one, yes? V equal acceleration multiplied by time. Or we can say V final equal V initial equal acceleration multiplied by time. They are the same thing. What is the V final here? 30, yes? Again, the same equation. Okay, V is 30 equal. What is the V initial? 0. We don't have V initial here, okay? Because this is the formula for when is the start address. Good? Plus, what is the acceleration? 2. What is the time? We don't know. Good? So, 30 equal, you know, again, here is 2t, yes? 30 equal 2t, you see? 30 equal 2t, 30 equal 2t. How? Divided by 2, divided by 2. T is going to be 15. Okay, T is going to be what? 15 seconds. I just wanted to show you this formula and this formula are the same. What is the answer then? 15 seconds. Okay, when a rock thrown straight upward, get to exact top of its path, its velocity is about 10 meter and its acceleration is 0. Velocity is 0 and its acceleration is 10 meter per second squared. The velocity is 0 and acceleration is 10 meter per second squared. Okay.
Velocity is 0, the acceleration is 10 meters per second.
Perfect. Yeah. You know, acceleration never change, constant in the free fall, and is always 10 meter per second and is always downward. It doesn't matter, okay, what the velocity is. Let's say velocity is 10 meter per second, 20 meter per second, 100 meter per second, 1000 meter per second. The acceleration is always downward and is always 10 meter per second squared. So which one is the right answer then? Question number 20. A bullet is fired straight down from the top of cliff. Let's say this is a cliff, okay. The bullet is fired from the top of the cliff, neglecting the air resistance. So it means that the acceleration is just g, yes? The approximate acceleration of the bullet in the meter per second is about 10. See, you know, same problem keep repeating, you know, with different form. Number 21. A ball is thrown upward, neglecting air resistance. So it means that the acceleration is again g, yes? What initial upward velocity, what is the initial velocity, yes? Does the ball need to remain in the air for 10 seconds? You don't need to look at the formula. No, up and down, okay? Traveling time. It should take 5 seconds to go up, 5 seconds to go down. What would be the initial velocity? That's it. Okay, you don't even need to use the formula, yes? Because you know that, every second the velocity decrease 10 meter per second, velocity increase 10 meter per second. The total traveling time is 10, 5 seconds go up, 5 seconds go down. Okay, what should be the initial velocity? 50 meter per second. Good? Okay. 22. The vertical height attained by a basketball player who achieved a hang time of full 1 second. This is a really good question. How high the basketball player can jump if he is in the air for 1 second? Which formula we are supposed to use first? Okay, tell me. Okay, look at the formula sheet, okay, and tell me which formula we can use.
Velocity plus acceleration.
How high? How high? Yes.
Distance half GT.
There you go. I find my equation. Perfect. Okay. I'm good. 50% solved. D equal 1 over 2 GT squared. G, I know that. Yes, it is 10 meter per second squared. 1 over 2 is the number. Okay, is half. Okay, I need to find the time. What is the time here?
1 second.
Time is 1 second.
Okay, so they're in the air.
1 second is in the air. That distance, okay, that we have in formula, this time is the time it takes to go up or it takes to go down. This is really important. Okay, in this formula, this time is a time to go up or to go down. It means that it's not total traveling time, yes? Not total traveling time. So what does it mean? If I'm just plugging the t here, what time should I plug? What is the total traveling time? 1 second, yes? How long does it take to go up? Yeah. The time that I need to plug is here is 0.5 second. Okay? So don't make this mistake. Okay, so again, read the question. Hang time means you are in the air.
Just the amount.
Yeah, you just, the player jump, yes? 1 second is in the air. What does it mean? It takes 0.5 second to go up, yes? 0.5 seconds to go down, okay. The time that I have at that formula is the time to go up or the time to go down, yes? Is not total traveling time. Make sense? So if I'm plugging the time, I should plug 0.5 second. What is the d value then? 1 over 2, 10.5 power of 2. What is the right answer? How high he can jump? 1.25, yes? Good?
Why is the t a distance, not the total time?
Because this is a simplified version of the formula. Okay, so I don't want to make it more complicated, confused. Okay, because you have seen this formula probably in the class. Xi plus VIT plus 1 over 2 AT squared. Good? Okay, if you haven't seen, don't worry about it. Okay, forget about it. Okay, just tell you that this time is not total traveling time. Is the time to go up or the time to go down? Good? Memorize that. Okay. Number 23. Read the problem, okay, and then, okay, let's read it together. 23. A man leans over the edge of a cliff and throw a rock upward at 5 meters per second. How far below the level from which it was thrown is the rock 2 seconds later? That's a really, really good question. It's a little challenging, but based on all problems that we have solved, okay, I think you are ready to solve these kind of problems. Just think about it, okay? Couple of minutes, okay? Those who are at home, okay, just you can even you can think on this problem as well. Yeah, you can draw the situation, okay? So first, which formula you are supposed to use? Which formula you are supposed to use? Again, this, yes? D equal 1 over 2 GT squared. You remember I said T is the time to go down or to go up. Which time we need to calculate? This is the time to go down, yes? From the top. Okay, think about it. How long does it take to go to the top, yes? It's gonna be the same time it takes to go from the top to the same location when it's thrown. We need 2 seconds after that, okay? See that? Okay, how much time it travel? The time to go up, yes? Plus the time it's going down from the same level, which is 2 seconds. What is this time? Okay, if you find this time, we are done. Let me just draw the situation, okay? So it was here, yes? It takes time to go up. Let's say same time to go up, same time it takes to be here, yes? Good. We need to find this time first, okay? But it's telling this D is not for this time. Even 2 seconds later, 2 seconds plus this time that we don't know. What is that time? You see, it's telling that 2 seconds later, which it was thrown 2 seconds later, because it reached here 2 seconds after this. What is this T then? How much it takes to go up? No, it's 5 meters per second. Okay, how long does it take to go up? We said that if it was 10 meters per second, it takes 1 second to go up, yes? Now it is 5 meters per second. How many seconds to go up? Half a second, yes? Good. You know, if it was 10 meters per second, it takes, 1 second to go up, yes? If this is 5 meters, it's going to be half a second. Good. Half a second to go up, and then it takes another half a second to go down. Okay, if we want to find this distance, okay, how much time we need? No, no, 2.5. Okay, read the question, okay? So the question is telling how far a man leaned over the edge of the cliff and thrown a rock. How far below the level? How far below the level? Okay, so what is the far below the level? This is the distance we need to calculate, yes? But we have a distance from here to here, okay? We can find this distance, we call it D. 1 over 2, 10, 2.5 power of 2, yes? What is the distance from the top to bottom? Calculate this. 2.5 times 2.5 is 6.25 times 10 divided by 2. Here is 31.25, yes? But we don't need this distance from here to here, yes? We just need this distance. Okay, what is this distance then? Again, we use the same formula, yes? To see how high it goes. D is gonna be 1 over 2 G2 squared. 1 over 2, 10. How many seconds it takes to go up? Half a second. Good. Power of 2. Good. Calculate this one as well. Let me just redo this problem. Okay, so it is. We have written too much stuff. Okay. Okay, let me just draw the situation. A man leaned over the edge of the cliff. Okay, a rock upward. Okay, cliff, yes. The velocity is 5 meter per second. Good. And it's how far below the level. This is the level, yes. How far below the level, okay, from the which it was thrown is the rock 2 seconds later. It means that when it is 2 seconds later here, yes. 2 seconds later when it is from the edge. Good. So how many seconds it goes to go up? 0.5 seconds, yes? And we can calculate this distance. Good. What is this distance? 1 over 2 gt squared. Good. 1.2, okay, 10.5 power of 2, yes? How much it is? 1.25, okay? So it means that this distance is 1.25. So if it takes 0.5 seconds to go up, it takes another 0.5 seconds to go down, yes? So what is the distance from here to here? Again, 1 over 2 gt squared, yes? 1 over 2, 10, yes? 2.5 power of 2, good? What is the 2.5 power of 2? 6.25, yes? Let me just 2, yes, 2.5 times 2.5. Yes, time divided by 2, yes, time by 10. It's going to be 31. 31, yes, 0.25. Okay, let me just calculate this one as well. Okay, 10, okay, 0.5 time, 0.5 time, 0.5 time, 0.5 is going to be 0.25 time 10 divided by 2. Okay, yes, 1.25. How far below the level which it was thrown, okay, is the rock 2 seconds later. So it's gonna be 31.25 divided by, okay, let me just see what is the right answer. Probably we are missing something. Okay, let me. Yeah, we need to change the wording. Okay, it means that the total traveling time is 2 seconds. Yes, good. Let me just do this. Okay, so what does it mean? It means that 0.5 goes up. Yes. 0.5 go down. Yes. The total time is 2 seconds. It means that it takes 1 second to go down. Yes. Okay, from the top to bottom, how many seconds it takes? 1.5. Yes. Good. But I thought that it was telling that 2 seconds after the level. Okay. It's not like that. It's 2 seconds is total traveling time. You just throw, okay. 2 seconds later, you see that it is how far below the edge. Make sense? You will say 0.5 second go up, 0.5 second go exactly where you thrown, okay? How many seconds left? 1 second left. Good. But what is the time from the top to the bottom? T is 1.5, yes? So now we can plug to this formula. 1 over 2 gt squared. 1 over 2 10 1.5 power of 2, yes? Okay, calculate this. Divided by 2, yes? Time 10. It's gonna be, what is this distance? 11.25, yes? But this is the distance from here to here, yes? What the question is asking? This distance the question asking. You remember we just said we calculate the distance when it's going up, 0.5 second going up, it's become 1.25. Good? Okay. 11.25, let me just use different column. 11.25, good? Minus 1.25, 11.25 minus 1.25 is going to be how many meter? 10 meter. Good question.
When it goes up 5 meters per second,
Yes.
it's 0.5.
10 meter per second. Okay.
I know you were explaining that, but like, is it because of gravity?
Yeah, it is because of the gravity. It's slowing down. Okay. Every every second the velocity decrease 10 meter per second. Yes.
Okay.
Okay. Let me just calculate this. Okay. Okay. We just have the, so V final equal V initial plus A time T, yes? What is the V final? It was here, yes? Now it is here. Good. What is the V final? 0. What is the V initial? 5 seconds. Plus, what is the acceleration? Negative 10, yes? Multiplied by time. When you just solve this, it's going to be 5 minus 10t. Good. Negative 5 both sides. Okay, cancel each other. It's going to be negative 5, negative 10t. Yes? Divided by negative 10, divided by negative 10. T is going to be 0.5 second. Good?
Okay. Yeah.
If you solve it, it's going to be, 0.1. Okay, so 0.5 second goes up. 0.5 second go down. Okay. The total traveling time was 2 seconds. Yes? It means that 1 second is going to be down. You calculate this distance, which become 1 over 2 gt squared, 1 over 2 10 1.5 power of 2, yes? It's become 11.25. But we need which distance we need? We need this distance. Yes, it means that we are supposed to calculate this distance, subtract from the total distance. What is this distance? 1 over 2 gt squared. 1 over 2 10.5 takes to go up, yes? And this become 125. Okay, you see, you want to calculate this. This minus this is going to be this, yes? 11.25 minus 1.25 is going to be 10 meters. I know this problem is a challenging problem, okay? You should not be expecting to have this kind of problem in the exam, okay? So, but it was good to analyze that, okay?
Oh, it goes up 2.5 meters, it goes down.
No, you cannot say that.
It wouldn't always look like that.
Yes.
Oh, that was.
Okay, let's move on to the next problem. We have more problem, okay, too. A kilogram is the measure of an object for mass. There you go. Force is Newton, yes? Weight is Newton, yes? Size is meter. Good? You. 25. An object maintains a constant acceleration unless there is a change in the acceleration is constant unless what is the acceleration? Look at the formula, yes? Net force divided by mass. And there is a, again, when there is a air resistance, yes? So it means that, yeah, there you go. Acceleration can change if we have a resistant force, okay? Or net force is changing. How the net force is changing? When there is a resistive force, yes? Applied force, yes. When F is changing, there you go. It mass, yes. It mass change, okay, the acceleration change. All of the above. So all of the above is the right answer. 26. Compared to the mass of a certain object on Earth, the mass of the same object on the moon is, if your mass here is, let's say, 70 kilogram. What is your mass on the moon?
Oh, what is that? Even.
It is the same. Mass is same, but weight is different. Because the weight is mass time g gravity. G on Earth is 9.8. G on moon is less than, Make sense?
Yeah.
So your weight will be different at different planet, okay, because your G is different. But your mass is going to be exactly, you're 70 kilogram here, you're 70 kilogram in moon, you're 70 kilogram in Mars, okay, anyway. So the mass of the object on the moon is the same. Good. Question 27. A 10 kilogram brick and 1 kilogram book are dropped in vacuum. The force of, there you go. The force of gravity, okay, so.
So if they were to drop a bowling ball.
Yeah, force of gravity. What is the force of gravity? Mass times G, yes? What is the mass of the brick? Let's say brick, okay, is going to be F equal 10 times G, yes? 10. It is 100. Good. What is the mass of the book? Book. F is, what is the mass? 1 time, what is the G? 10. How much it is? 10. How many times bigger than? The mass of the force of gravity on the brick is how many times bigger than? This is 100, this is 10. 10 times as much as. Make sense? Okay, again, force of gravity is the weight. Force of gravity is m times g, or the weight of that object. The weight is the force of gravity. 28. The Newton is a unit of force, yes. 29. An object is propelled along a straight line path in a space by a force. If the mass of object somehow becomes twice as much, its acceleration will be, look at the formula, yes? Acceleration and mass are how they are related to each other? Inversely related to each other, yes? Because acceleration is going to be F net divided by mass. An object is propelled along a straight line, path in a space by a force. If the force is same, but it's telling that if the mass of object somehow become twice, this mass be doubled, what happened to the acceleration? How mass and acceleration are related to each other? Inversely related, yes? Sorry. Good? If the mass become 2 times, what happened to the acceleration? Become half. Okay? So you see here, let's say the force is 10 Newton, the mass is 10 kilogram, yes? What is the acceleration now? 10 divided by 10, yes? It is 1 meter per second, it's good. If I change the mass, good, to 5 kilogram, good? But keep the force, same force. So 10 Newton divided by, instead of 10, I just put, sorry, it's telling 2 times, yes? Let's say, make it 20. Good? 20 kilogram. What happened? 10 divided by 20, 0.5 meter per second square. What happened to the acceleration? It got smaller, yes? Because mass and acceleration are inversely related to each other. If you twice the mass, acceleration become half. If you triple the mass, okay, the acceleration become 1/3, yes? If you 4 times the mass, okay, the acceleration become 1/4. Good? What happened here? Half. So if you half the mass, what happened to the acceleration? 2 times bigger. If you 1/3 the mass, okay, acceleration become 3 times, okay? 30. A 10 Newton falling object encounter 4 Newton air resistance. What is the net force?
Let me look what that force is. Oh, it's just a sum of the forces.
Yeah,
6N?
6N, yes. What is going to be the direction?
Falling goes down.
10 is down, yes. 4 is up, yes. 10 is bigger than 4, yes. So it means that, they adding, but they add with the sign. So let's say 10 is going to be negative 10 plus 4 is positive 4, yes. What happened? It's going to be negative 6 Newton.
Just the direction.
There you go. Negative means that this is the resultant, yes, 6 Newton, but this negative means it is down, yes? But here is not asking for the direction. It's just asking for magnitude. 31. An apple at rest weight 1 Newton. The net force of the apple when it is free fall is
How would we figure that out?
okay. What is the force of gravity? We said that force of gravity is weight, yes? The only force which is exerted on apple is the force of, and what was the force of gravity? Weight. What is the weight of the apple? Okay, force of gravity is going to be what? There is no air resistance. If there was air resistance, that would be different. Because the force of gravity is the weight. Earth is trying to pulling apple toward itself. With what force? Force of gravity. With its weight. Okay. What is the weight of the apple? 1 Newton. "32. The maximum acceleration of a car while towing a second car twice its mass compared to the acceleration with no car in tow is same, 1/3, 1/2, 1/4, or none of these." Draw the situation. Okay, let's say there is a car, the mass is m, yes? And now this car is towing another car. What is the mass of the other car? How many times is bigger than? If this is m, this is going to be 2m, yes? What happened to the acceleration? Acceleration inversely related to the mass, yes? The mass was m. Now, what is the total mass? 3m. How many times is bigger? The mass is 3 times bigger. What happened to the acceleration? Let's go. Good. Analyze this way. Okay, the mass was m. Okay, now it's just pulling. Not only it's pulling its mass. Okay, it's pulling another 2m, 2 times bigger than. Okay, so how much the mass of the system has changed? The mass was m. Now it's 3 times, because you need to consider the mass of the car itself as well. Good. It's the 3 times mass. What happened to the acceleration? 1/3. 33. 1 kilogram mass at the Earth's surface, weight about. Weight formula was what? mg, yes?
Is it 10?
Yes.
Okay.
Yeah. Because mass times g, yes? Yeah. Weight is mg. What is the m1? What is the g10? It's going to be 10 Newton. 34. Hang from a pair of gym rings, and the upward support forces of the rings will always. Hanging from a pair, yes? Ring. And upward support.
The person hanging?
Yes, the person hanging.
Is it equal?
Yeah. Because the weight of the person, yes, let's say person, yeah. This is the weight, yes, and this is a 2 ring, yes. Okay. And these 2 tension, yes, they have to be balanced, yes. 2 tension should be equal to the weight of person. So the weight should add up to, add up to equal to your weight. Okay. These 2 tension force. Good. 35. A girl pulled on a 10 kilogram wagon with a constant horizontal force of 30 Newton. Okay, let's say this is a wagon and 30 Newton. There are no other horizontal forces. What is the wagon acceleration? What formula we are supposed to use? This one, yes? Acceleration is, what is the net force? 30. What is the mass? 10 kilogram. Good. 30 divided by 10. 3 Newton per kilogram or 3 meter per second squared. Good. Other unit of the acceleration is Newton per kilogram. 36. A bag of grocery has a mass of 10 kilogram. What is its weight? Mass times G. Oh yeah. What is the mass?
100.
Yes. Thirty-seven. An object following a straight line pass at a constant speed. Constant speed, it means that no acceleration, yes? No acceleration, it means that net force is 0. What does it mean? Which one is the right answer? Which one is a better answer? B? No, it still has a net force. When there is a net force, yes, there is there will be acceleration. And when there is acceleration, it means that the velocity is changing, yes? The velocity is not changing. The velocity is constant. So what happened to the acceleration? Acceleration is 0. Acceleration is 0, yes? F net divided by mass. When acceleration is 0, F net should be 0, yes? So which one is the right answer? 0 acceleration? Well, how about this then? Which one is better? No force acting, it means that the net force is 0, yes? But I have some situation that there are forces, yes?
Yeah.
But they are canceling each other. Good. So let's say 4 Newton to the right, 4 Newton to the left, yes? What is the net force? What is the acceleration? 0. The object is moving, let's say, with a constant velocity, yes? Okay, so this is not the right answer. This is the right answer because there are situations, there are forces, and these forces cancel each other, and net force becomes 0. If it was telling net force is 0, yes, that would be the right answer. Good? But there are some situations, okay, there are forces, but these forces cancel each other. So the best answer is acceleration 0. 38. So when a woman stands at rest with both feet on a scale, it reads 500 Newton. When she gently lifts one foot, the scale reads
Like off of it, or she's just
no,
suspended
just
foot.
yeah, 1 foot. It's gonna be what? 500, less than 500, or more than 500? What do you think?
Huh? Wouldn't it still be 500?
Yeah, why? Because the weight is gonna be the same weight. Okay, so your weight hasn't changed. Okay, so you are just having the same weight, but instead of 2 foot, you have 1 foot. Okay. The answer is 500. 39. A rocket becomes progressively easier to accelerate as it travels upward from the ground, mainly because the mass of the rocket decreases as fuel is burned. The gravity becomes weaker with increased distance. The applied force on the rocket increases as burning of the fuel progress. Acceleration and mass are inversely related to each other, yes? Which one describing that? Accelerating more, what happened to the mass? Get smaller, yes? The mass is getting smaller, that's why it's accelerating more. So which one is the right answer? Which one? You know, the mass of the rocket decrease, okay, because the rocket has fuel, yes? The fuel has a weight. This fuel burn. The weight gets smaller, yes? When the weight gets smaller or mass gets smaller, okay, what happened to the acceleration? Acceleration increase. Okay, good. But here it's telling that, yeah, it's burn, okay, but it doesn't mention, you know, what happened to the mass, you know? But the applied force is going to be the same applied force, okay? Applied force is not going to change. 40. A block is dragged without acceleration in a straight line path across a level surface by a force of 6 Newton. What is the force of friction between the block and the surface? See, what happened? Without acceleration, yes? Acceleration is 0. So what does it mean? Net force is 0, yes? F net is 0 because acceleration is 0. If it's, you know, what happened? There are forces and these forces, you know, cancel each other. So if there was a 6 Newton to the forward, yes, there is another 6 Newton backward, which is the friction force, good? And these two, when you add, they cancel each other. That's why the net force becomes 0. That's why the system moving with the constant, no acceleration. It can stop or it can move with the constant velocity. Good? 41. A 1 kilogram rock that weighs 10 Newton is thrown straight upward at 20 meters per second. Neglecting air resistance, the net force that acts on it when it is halfway down to the top of its path, it is still, the weight doesn't change, yes? Yeah, because the force of, you know, there is no air resistance, yes? It's going to be exactly about 10, yes? A skydiver of a mass of 100 kilogram experienced a what air resistance? 500 air resistance. Okay. What is the right answer then?
It's not 500. Is that an equation that we could use?
A skydiver, okay, has a mass of 100 kilogram, experience air resistance 500 Newton, yes? And an acceleration of, what is the net force? 500, yes? What is this? 100, yes? It's gonna be this, yes? 5. Which one is the right answer? 0.5 times 10 is gonna be 5, yes? This is the right answer. They just use 0.5 G, okay. 0.5 G is the 5. Okay, 43. A 10 kilogram block with an initial velocity of 10 meters per second slide 10 meter across horizontal surface and come to the rest. Good. So what was the velocity at the beginning? 10 meter per second. Good. What happened to the velocity? 0 meter per second. Velocity is changing. The system is slowing down. Yes. There will be acceleration. If the velocity is forward, the acceleration will be backward because it's slowing down. Okay. And it's telling what is the stopping force? Force is mass time. I need to find the acceleration. Yes. How can I find the acceleration? Go to the acceleration formula. Yes. What is the acceleration? There you go. Change in velocity over change in time. Do we have a time? Yes. It's telling that 2 seconds later stop. What is the final velocity? 0 minus initial velocity. Good. Divided by what is the time? 2. What is the acceleration here? Negative 5 meter per second squared. Good. Okay. What was the force? Net force. What is the net force? F is equal mass time acceleration. Good. What is the mass? 10 kilogram. What is the acceleration? Negative 5 meter per second square. Good. It's going to be negative 50 Newton. We need just magnitude, yes? These negatives just show the direction of the force. Yes, it's going to be in this direction, which is going to be in the same direction the acceleration is. And it makes sense. Okay. We have just 2 minutes. Okay. So how many questions left? I think we have 44.
So many.
Okay. They are. Okay. We just did 60 something. Okay. We just did until 44. Okay. So tomorrow I start from 45. Good. I start from 45 and then I complete this part and then we do the second part, which is the graph problems. Okay. Good.
I will
Okay.
give you 12 tomorrow.
That's all right.
Have your email.
Yep.